All right. Here's another video key for this time PA 11.3, solving absolute value equations and inequalities. First, just got a couple of definitions. We have absolute value. So absolute value is defined as the distance a number is from zero on a number line. That's something I'm going to talk about or reference throughout this video key. An extraneous solution is a new thing. Basically, you find a solution to an equation, you do everything correctly, but the solution still does not work. So you got to check all of your solutions on these problems. That gets a little tedious. So on a test, I usually just have a section where I make you check for extraneous, and I have a section where there won't be any extraneous solutions. That way you only have to check a couple times. But it is important to know that extraneous solutions are things that can exist in certain equations that we solve. Okay, so looking at absolute value. Since absolute value means the distance from zero on a number line, this means your distance has to be 18. Well, there are two different numbers whose distance is 18 from zero on a number line, and one number is 18, and the other number is negative 18. A negative number on a number line just means you're moving to the left instead of to the right. So these are the same distance from zero. Okay, on all these problems, I've highlighted the part that's inside the absolute value, because this is the thing that will be a distance of 3 from 0. So this number right here, whatever it is 3 from 0 on a number line. That means we can either find when this equals 3, or we need to find when this equals negative 3 also. So just because if this equals 3, then the absolute value of it, or the distance from 0, is 3. If this equals negative 3, then the distance from 0 is still 3. And so you set up two different equations like this, and you just solve them both. And then if you check real quick, negative 4 plus 7 is 3, and that is a distance of 3 from 0. And negative 10 plus 7 is negative 3, which is also a distance of 3 from 0. Remember, that's what these bars actually mean, how far from 0 on a number line. Okay, so on number 5, same thing. This represents some number, which is 18 away from 0 on a number line. So that number is either 18 or negative 18. And then we find the x value that gives us those two numbers. Notice how on number 4, you can't just find one answer and then change the other answer to either positive or negative version of that. That's not how these work. It did happen on this problem, but it certainly does not happen all the time. In fact, it usually doesn't. So on number 6 here, once again, this number has to either be 18 or negative 18 to be 18 away from 0. Remember, how far from 0? You're either 18 away from 0, which means you're 18 to the right, or 18 to the left. That's all this means. So you set up your two equations. I'll let you look at the steps, but you can see how we get x equals 6 and x equals negative 12. Two completely different numbers. 7's a little bit trickier because now over here we have variables. So it's okay though. This is still a distance from 0, and your distance from 0 has to be 4x plus 5. Well, you can either be 4x plus 5 to the right on a number line, or you got to do where this thing inside the absolute value could be negative this also, because that's just the other direction on a number line. And so that's why it's negative 4x minus 5. So you just make these opposite of what they were. If it was a minus 5 to begin with, then you'd make it a plus 5 down here. Or if it was negative 4x to begin with, you'd make it positive 4x down here. And then you have two separate equations. So solve these however you like. There's a bunch of different steps you can do. You can see what I did though. Get your solutions. Now on this one, if you plug in negative 3, which I've shown down here, you plug in negative 3, you get absolute value of negative 7, but that means the distance from 0, and that distance should be positive 7. But on the other side, we got negative 7, which is not possible. And so x equals negative 3 is called an extraneous solution. We found it correctly up here, but it still does not work in the equation. X equals negative 1 does work. Here's the work for that. You can see. Okay, now we do inequalities. So again, with inequalities, this is saying the distance from 0 is bigger than 2. So what numbers have a distance from 0 bigger than 2? Well, numbers bigger than 2, 2, 3, 4, 5, etc. But what other numbers have a distance that's more than 2 away from 0 on a number line? And those numbers are negative 2, negative 3, negative 4, etc. So all numbers less than negative 2. And then this, since here, as opposed to equations up here where we just find a couple answers, there's infinitely many answers down here. So we write it in interval notation. This is negative infinity up until negative 2. This is starting at 2 and then numbers bigger than 2 forever. And that's where we use a union symbol as we've learned in the past. Okay, now number 9, almost the same question, but our inequality symbol is switched. This is asking us what numbers are less than a distance of 2 away from 0 on a number line. Well, that would be like the number 1, 1/2, but then also negative 1 and negative 1/2. So you find when x is less than 2, but at the same time, x has to be greater than negative 2. Because if you get to negative 3, that's 3 away from 0, which is not less than 2. So remember, this means distance from 0 on a number line. And in interval notation, that looks like this. So same thing down here, as we talked about with equations. This number has to be less than 12 away from 0 on a number line. So if the number itself is less than 12, but at the same time it has to be greater than negative 12, because if it gets to negative 13 is 13 away from 0, and that's too far. You got to be less than 12 away from 0. Remember, these bars mean away from 0. So you can see how I solved it there. All right, when you get to 11, now we need numbers that are more than 12 away from 0. So any number bigger than 12 will be more than 12 away from 0, but also any number less than negative 12 will be more than 12 away from 0 on a number line. You can see the steps here, and then here's our interval notation as we discussed in a previous problem on this video. So same thing is going on here. Now we need to be less than 18 from 0 on a number line. So either that number has to be less than 18, but it can't be every number less than 18, like negative 100. Negative 100 is 100 away from 0. So there's a stopping point, and that stopping point is just negative 18 itself. So you have to be less than 18, and at the same time, you have to be bigger than or equal to negative 18. Notice how this one has or equal to. That just changes our interval notation to brackets rather than parentheses, but you can follow the steps. The steps are the same, but the numbers are different in the end. And so it looks like that. We can also graph these answers on a number line, but I just didn't ask you to do that on these particular problems because we should have done it enough by now if you've done all the problems I've asked you to do. And then 13, now you need the distance from 0 to be bigger than 18. This is the number we're talking about. We need this to be bigger than 18, which will make it more than 18 away from 0, but also a number less than negative 18, like negative 25. That's 25 away from 0. So if you're either bigger than 18 or less than negative 18, you'll be more than 18 away from 0 on a number line, which is what this means. And so you can follow the steps here and see the interval notation. But that's it.